Alrighty, students. So in problem number 5, um, it states that a tennis player makes a successful first serve 51% of the time. Assume that each serve is independent of the others. If she serves 9 times, what is the probability that she gets at most 3 successful serves in? So please note that in problem number 5, you're going to need to use either the binomial PDF or binomial CDF command. Um, and uh, Depending on the wording of the problem, if it uses any one of these keywords like exactly X, where X is some numerical value, less than X, at most X, more than X, or at least X, those are one of the 5 formulas per se that you can use based on the keywords. Now note that, right, this is just a conceptual note. Note that for problem 5, we are using a binomial command because the data that we're given, the variable, is talking about the the number of times that a tennis player makes a serve. So the number of serves are going to be what we call discrete data. And anytime you're dealing with discrete data, you're essentially going to be using the binomial commands, or binomial PDF or binomial CDF, or in short, as binomial probability. If we're dealing with continuous data, like some sort of measurement, then we will use the normal PDF, or more importantly, normal CDF. So I just want to make that quick note. Okay. So first thing is, we got to choose which one of these formulas we're going to use now based on this problem. Well, the key word here is going to be at most. So since I know that I have an at most case, I just need to know how to use the formula for at most. Well, at most means that I have to do the binomial CDF, which is basically stating the values of n, p, and x. N, which is the sample size, or the number of individuals or objects. P is your success rate, and X is the number or the desired number of successes. So for us, we were trying to find the probability of getting at most 3. So at most means, by the way, that we're dealing with 3 and below. So that's considering getting basically a 0, 1, 2, or 3. So the binomial CDF takes care of this for us. This is going to equal to the binomial CDF. And then we just got to state what's the values of n, p, and x. So the value of n is basically your number of trials or sample space, or size of your sample size. So that's going to be your n. Your n is 9. Your success rate would be 51%. But as a decimal, you put it as 0.51. So that will be your value of p, your success rate. And x is the number of successes we want. That would be 3, right? So we want at most 3, so we just call it 3 for now. So how do I do this in my calculator? In the Ti84, what you first have to do is hit second vars, okay? So you do second vars to get the different type of distributions. Now on your list, you want to use the binomial CDF command. If I use the binomial CDF command, I click on it, and then you enter your values of n, p, and x. So we have n is 9, so I do 9, comma, value of p, which is 0.51, comma, the value of x, which is 3, close parentheses. I get a value, and I round it to 4 decimal places. This will be 0.2346. So that's how you would do it, essentially in a graphing calculator. Now, let's say if they change up the wording, like let's just say that they want to find the probability of getting exactly 3, for example. The difference between at most 3 and exactly 3, in the exactly cases, you're using a PDF command. So you would need to do binomial PDF. And then you would do the values 9, p, sorry, the values of n, p, and x. So they all stay the same, 9.51 followed by 3. So if I do this again in my calculator, you would do second vars, select not binomial CDF this time, but actually select the one above it, binomial PDF. And you enter your values. So 9, comma, 0.51, comma, 3. And if you hit enter, you're going to get a slightly different answer. This time we're going to get 0.1542 if I round it to 4 decimal places. The ones that you have to be more careful with are examples like more than and at least. If you want to do the more than or the at least case, you would need to essentially do a binomial, you need to use a complement rule, right? The binomial CDF starts usually at 0 for the value of x. So it starts at 0 and it ends up to whatever the actual value of x is, or x minus 1. But first, in your calculators, you always got to do the 1 minus part first. All right, so just to show you one example, let's say if I want to do the probability of at least 3. So at least 3 would imply that I want to basically get x equals 3, 4, 5, 6, 7, 8, 9. So that implies that when you're dealing with the at least, it's going to be 3 or more. So for us, you're looking at our rule, we have to use the last one. It will be 1 minus binomial CDF of 9, comma, 0.51, comma, the value of x minus 1, right? Because 3 is going to be included in at least, then I have to subtract that off for the binomial CDF. We want it to stop at 2 rather than 3. So therefore, the complement rule, the 1 minus this answer, will give us at least 3. So how do I do it in the calculator? Well, first, you hit the number 1, then you hit minus, then you do the binomial CDF stuff. So you do second vars, binomial CDF, value of n, comma, value of p, comma, value of x, comma. Sorry, not comma, close parentheses. And then you hit enter. If you look at the binomial CDF here, 1 minus binomial CDF, we're now going to get approximately 0.9196, right? So just be mindful of the key word in the problem, okay? Then from there, figure out, okay, from the keyword, which one of these commands I can do, write out that command along with your values of n, p, and x, right? If you have the more than or at least case, make sure you do 1 minus binomial CDF, right? So 1 minus got to happen first in the calculator, then binomial CDF of whatever. If it's going to be the exactly case, just make sure that you're using a PDF rather than a CDF. And those are essentially your solutions to problem 5.